Hello, Chem1B. This is our solution chapter lecture video 10, and it is our last video for this chapter. So it's about colloids. Colloids are a type of mixture. They are what we call a dispersion of one substance in another. They are not true solutions. So these are more often called something called a heterogeneous mixture, something that you learned at probably the very beginning of Chem 1A. Now, one of the cool things about a colloid is the particle size is pretty big for a molecule or a particle. In chemistry, this may not look like a very big particle to you, 1 to 1,000 nanometers in size. Nano is a really small unit, but for particles in molecules and whatever, that is big. That is like a big clunky molecule. Now, when they mix together, we form, like I said, heterogeneous mixtures. This is where they're unevenly dispersed in one another. Now, some colloidal particles kind of fall into two different kind of groups, either agglomerations of atoms or molecules, or they're big macromolecules. So what is an agglomeration? An agglomeration is where basically all these atoms and molecules, they're separate particles, but they all got stuck together as one big particle, generally via intermolecular forces. So the intermolecular forces are holding all these atoms and molecules together in this one big clunky particle. Whereas a macromolecule is just a really, really big molecule. Think a protein or an enzyme. These are technically macromolecules, or often known as supramolecules, because they're so big. Their molar masses are in the tens of thousands. These are examples of where you might see a colloidal particle size. Now, colloids typically scatter light since they are comparable in size to the wavelength of visible light. So remember, visible light is around 400 nanometers in the UV/purple area to up to about 800 nanometers in the red light range. And if you notice, that falls kind of just right around where this particle size is. Now, because the particle size is similar to the wavelength of visible light tends to bounce off of these particles much more frequently, and that causes the light to scatter. If you've ever taken a driver's license test in California, one of the questions that I always got asked back in the day was, should you use your high beams in fog? And the answer is absolutely not, because fog is actually a colloidal mixture and it scatters light. And the higher beam you have, the more light gets scattered, and your visibility actually decreases due to that light being scattered. Now, one other thing I need to talk about in terms of colloids is the difference between two different heterogeneous types of mixtures, which is one is colloids and the other is known as a suspension. Now, a suspension is also a heterogeneous mixture, but the big difference here is that suspensions tend to separate from each other on a much, much, much faster time scale than a colloid does. Colloids often don't separate at all. Or if they do separate, it just takes a very long time. So think about some examples of suspensions. Nutella is my favorite example of a suspension because honestly, it's like my guilty habit. I love Nutella. But if you've ever left your Nutella sitting for a very long time and you haven't used it in a while, which I know probably nobody does because it's so delicious, but if you do, you might open it and find that there's like this layer of oil on the top of your Nutella, and all the chocolatey goodness, hazelnut stuff is down below it. Now, don't think that this means your Nutella has gone bad. It's just because Nutella is a suspension. And what happened is it separated the oil and the Nutella, like the nut cream, basically separated from one another. Colloids don't do this, whereas suspensions do. So for our last slide of this chapter, we're going to talk about the different types of colloids. Now, so when we talk about our colloids here, this is our name of our type of colloid. And then this first column is my solute, and this column is my solvent. So the first column is what is dispersed in the major component, the solvent column. So an aerosol is a type of colloid. A big example of this is fog, and it's where we have little tiny water droplets or liquid droplets dispersed through a gas. In this case, in fog's example, it's water droplets dispersed throughout air, which is a gas. Then we have solid aerosols, which are another colloidal mixture. And in this situation, it's similar to an aerosol, but instead of a liquid particle, it's a solid particle. So smoke is a great example of this. That is ash dispersed throughout a gas, in this case, air. And so that's solid aerosols. Foam is a gas in a liquid. And again, one of my other guilty pleasures, whipped cream is an example of a foam, or shaving cream is another one. And in this, we have in whipped cream, it's air bubbles dispersed in a liquid. So this is kind of like the opposite of an aerosol. So you have the gas being the particle and the liquid being the substance it's dispersed in. Then we have emulsions, which is a liquid within another liquid. And a good example of this is milk. Milk fat globules are dispersed throughout water. Water and fats generally not very soluble, very different IMFs between those two different substances. And so it's just a dispersion in one another's. The last type of colloid is a solid emulsion, and this is where you have a liquid dispersed throughout a solid. A good example of this is opal beads. Opals are silica glass, that's the solid part, and inside that glass there's pockets of water dispersed throughout the opal. Now those pockets of water reflect light, and that's what gives them that like pretty blue color. So it's kind of cool. These are colloids. And if you have any questions, as always, please do not hesitate to ask me. I'm always happy to help. And this is our last video of our solutions chapter.